In this video, we're going to start talking about the discriminant. Determining the number of zeros of a quadratic function. Recall that if ax squared plus bx plus c equals 0, then x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Now the part underneath the square root is called the discriminant, and I'm circling it right there. The discriminant is b squared minus 4ac. Well, if b squared minus 4ac is less than 0, then we have a negative amount underneath the square root. So what that means is there are no zeros or x-intercepts or roots. Now, technically, it means that there are no real values of x that make the quadratic equation true. There might be non-real values of x, but for our purposes, we'll say that there are none because we'll assume we're talking about real numbers. Now, if b squared minus 4ac equals 0, then what we'll get is negative b plus or minus the square root of 0 all over 2a. Well, the square root of 0 is it's negative b plus or minus 0 all over 2a. Well, if we take negative b and add 0 and put it over 2a, we'll get negative b over 2a. Or if we take negative b and subtract 0 and put it over 2a, we'll still get negative b over 2a. What we'll have are two different answers that have collapsed into one. So what we'll say is that there's one 0 or x-intercept or root. And finally, what if b squared minus 4ac is greater than 0? Well, then what we'll have is a non-zero value for the discriminant. When we take the square root of that, we'll get a non-zero value. And so when we have negative b plus that value divided by 2a, or negative b minus that value over 2a, we'll get two different answers. And so assuming we're in the real number system, which we will, of course, unless ever said otherwise, then there will be two zeros or x-intercepts or roots. So let's put this to work. Imagine we had the function y equals 3x squared minus 10x plus 2, and we wanted to know how many zeros there were. Well, it would be pretty easy to find out what the zeros themselves are by simply using the quadratic formula. But this step, since it's only asking us how many there are there 0 or 1 or 2, all we'll do is say, well, b squared minus 4ac is simply equal to, since we know a is 3 and b is negative 10 and c is 2, what we'll say is that b squared minus 4ac is negative 10 quantity squared minus 4 times 3 times 2, which is 100 minus 24, which is 76. So since the discriminant equals 76, there are two zeros. And what we have graphically is a parabola that looks something like this, where it's a quadratic function, so it's a parabola, and there are actually two x-intercepts graphically. Now, what if we have the equation 5x squared plus 2 equals 3x plus 1? Well, what we can do is make one side equal 0 and do the proper algebra there, and we'll end up with 5x squared minus 3x plus 1 equals 0. Now, at that point, we'll see that a is 5 and b is negative 3 and c is 1. And we'll see if we can figure out if there are any solutions to this. Well, b squared minus 4ac, given these values of a, b, and c, will end up ultimately equaling negative 11. So in other words, we'll have a negative sign underneath the square root, so there will be no zeros at that point. If we were to express this graphically, we would have a parabola that never touches the x-axis. You can see here there are no values that equal 0. And finally, what if we were given the function h of x equals 8x squared minus 8x plus 2? Well, we see here that a is equal to 8, b is equal to negative 8, and c is equal to 2. So b squared minus 4ac would be negative 8 quantity squared minus 4 times 8 times 2, which ultimately equals 0. So since the discriminant b squared minus 4ac is equal to 0, there would be one root. And if we were to express that graphically, it would look something like this. There'd be a parabola, and it touches the x-axis at exactly one point. And finally, we'll do one more. If we had the function k of x equals 9x squared minus 10x plus 2, the value of our discriminant would ultimately equal 28. And since the discriminant was greater than 0, we would say that there were 2 real roots. And again, for our purposes, we'll say there are 2 roots. We're not talking about the non-real numbers in this section. Now, let's take a step aside for a moment and have a discussion about quadratic inequalities. A quadratic inequality happens when you have one of these symbols, less than, greater than, less than or equal to, or greater than or equal to, and the variable has an exponent of 2. When that happens, what we're going to try and do is get the variable on one side and the number on the other and take the square root of both sides. But it's important to remember that the square root of x squared is not x, it's the absolute value of x. And that's what it says here. In other words, the square root of x squared is the absolute value of x. I'll show you a mistake people make. They say, well, the square root of x squared is automatically equal to x. Not necessarily. Let's imagine for a second that x was equal to 3. Well, the square root of x squared would equal the square root of 9, which would equal 3, which in that case would equal x. So we see it's sometimes true. But what if we let x equal negative 7? Well, then the square root of x squared would be the square root of negative 7 quantity squared, which would be the square root of 49, which would be 7, which would not be x. X is negative 7. However, that 7 would be equal to the absolute value of x, because I think we would all agree the absolute value of negative 7 is 7. So it's important for us to know that sometimes we have to make that distinction. Well, we always have to make that distinction, and sometimes it can have a very real effect on our answer. So let's see what this means for solving a quadratic inequality on the next slide. Suppose we wanted to solve the quadratic inequality x squared minus 16 is less than 0. Well, what we're going to do is we're going to get the variable on one side and the number on the other. So add 16 to both sides, we get x squared is less than 16. At this point, we'll take the square root of x squared and we'll say it's less than the square root of 16. Well, the square root of x squared is the absolute value of x, and the square root of 16 is 4. So the absolute value of x is less than 4. Now, this means that the distance of x from 0 is less than 4, because absolute value means the distance from 0. So the distance of x from 0 needs to be less than 4. Well, if I look at a number line, I see that at these two values that I'm circling here, the distance from 0 is equal to 4. So if I'm going to consider values that have a distance from 0 less than 4, I'm going to be considering all of these values that I'm shading, but I'm not going to be considering the 4 or the negative 4. So we can say that showing that here one more time, we can say that the answer would be all of the x's that are elements of the reals such that negative 4 is less than x is less than 4. And that would describe this interval there. Well, what if we had the quadratic inequality x squared is greater than or equal to 9? Well, we've already got the variable isolated on one side. So we're going to take the square root of x squared on the left, and we're going to take the square root of 9 on the right. The square root of x squared is the absolute value of x, and the square root of 9 is 3. So at the values I'm circling now on that number line, that's where the distance from 0 is equal to 3. Then if we want a distance from 0 greater than 3, we'll be talking about values to the left of negative 3 or values to the right of 4. And so again, showing those on the screen, we'll want to include the negative 3 and the positive 3, as well as values to the right of positive 3 or the left of negative 3. And so we'll be able to say that our solution set is equal to the set shown. So let's take this new knowledge and go back to discriminant work. What if we wanted to determine the value of k such that f of x equaled x squared minus 10x plus k had one x-intercept? Well, looking at this expression, I would see that a is equal to 1, and I would see that b is equal to negative 10, and I would see that c is equal to k. So I would know that b squared minus 4ac had to equal 0 because there's one x-intercept. So ultimately that would mean that 100 minus 4k would have to equal 0. And that would mean that negative 4k equaled negative 100, or in other words, k equaled 25. Now, what if we wanted to determine the values of k such that the expression 4x squared plus kx plus 4x squared plus kx plus 100 had two solutions? Well, we would see that a is equal to 4, and b is equal to k, and c is equal to 100. And so, since it has two solutions, we would see that b squared minus 4ac would have to be greater than 0. So that would mean that k squared minus 4 times 100 would have to be greater than 0. K squared minus 1600 had to be greater than 0, meaning k squared would have to be greater than 1600. At this point, we have our quadratic inequality right how we like it. We take the square root of the left-hand side and the square root of the right-hand side, remembering that the square root of k squared is the absolute value of k, and the square root of 1600 is 40. So the absolute value of k would have to be greater than 40. Looking on a number line, we would see that if 0 was here, negative 40 was way out to the far left, and positive 40 was way out to the far right, we would see that we would be including values to the left of negative 40 and to the right of positive 40, but we wouldn't be including negative 40 or 40 themselves, and we'd be able to write our solution set. Now, what if we wanted to determine the values of k such that g of x, as shown, had no x-intercepts? Well, we would see right away that a is equal to negative 2, and b is equal to negative k, and c is equal to negative 18. We'd know that b squared minus 4ac would have to be less than 0, meaning negative k quantity squared minus 4 times negative 2 times negative 18 would have to be less than 0. Negative k quantity squared is k squared, and we would ultimately have minus 144 is less than 0, meaning k squared would be less than 144. Taking the square root of k squared and the square root of 144, we would see that the absolute value of k would have to be less than 12. So on a number line, we would see that we would have numbers in between negative 12 and 12, because those values would have a distance from 0 less than 12. And so our solution set would be as shown on the bottom of the screen. And what if we wanted to determine values of k such that the function shown had two x-intercepts? Well, in this case, we'd see that a was equal to 5, and we'd see that b was equal to negative 12, and c represents everything not attached to an x at all. So c would actually be equal to k plus 3. Now, the b value represents the coefficient of x, so if we had k multiplying x somehow, that would be part of the b. And the a value indicates everything multiplying x squared, so if somehow k was part of attached to an x squared, it would be part of the a value. But in this case, the k plus 3 is unattached to x or x squared, so there's our c value. Now, we see b squared minus 4ac has to be greater than 0. So that means negative 12 quantity squared minus 4 times 5 times k plus 3 is greater than 0. Now, negative 12 quantity squared is 144. Subtracting 4 times 5 times k plus 3 is the same as subtracting 20 times k plus 3. And ultimately, what we would get after we did some distribution is that 144 minus 20k minus 60 is greater than 0. In other words, 84 minus 20k is greater than 0, and isolating the k, we would get negative 20k is greater than negative 84. Well, this is not a quadratic inequality because there's no exponent of 2 on the k. This is a linear inequality, so it's actually relatively straightforward to answer. All we have to do is divide the left side by -20, divide the right side by -20, and since we're dividing by negatives, we'll just remember to change the direction of the inequality operator. So we'll end up with k less than -84 over -20. Dividing numerator and denominator both by -4, we see k is less than 21 over 5, and that's our solution set.